Good day everyone. Today we are going ahead with the same models, solid models that we saw last time. We are going to make them. Making makes us understand them better. Of course, seeing them and handling them makes us understand easily. This is still better. And so we are going to learn how to make them. Now, we are going to make a cone and a cylinder with curved surfaces and pyramid, prism, cuboid and cube which have flat surfaces. Okay, so now the cone and the cylinder, they both, it seems that they are not flat and straight, so they should be difficult, but they are in fact easy, because as you can see, cylinder, you can just take the paper that you want and fold it and glue it up here, and then depending upon the circles that you have here, you make 2 circles and glue them up here. Also, gluing the circle will take together with the, when we talk about gluing the circle in a cone. So that is the cylinder. For a cone, you take a circle and you take, this is I think the same circle, yes. You take the height from the center to the radius, to the circle, that is the radius, that will be the height, because we are going to fold like this. And this will be the height of your cone, this much. Now before we fold, we don't want to take the whole circle. What we do is, we take only that much part, we cut along 2 radii, and then we fold in such a way that this will overlap. And of course you have to be exact. So then this is our cone. Now I have taken the radius very small, so it looks like a very flat cone. You can make it narrower by taking it like this. You can make it still narrower like this. And now the circle in cylinder as well as in this. What we do is, we take, suppose this is the circle we want to fit in here. Before that, what we do is, we take the cone a little longer than we want, the radius a little more than what we want. So suppose that the radius that we wanted was this much. Then we take a little more, and what we do now is, this is the radius that we want. We put small cuts at distances, and then if this is this circle and this is your cone, this of course this is cylinder, we can take it this way. Okay, yeah. This is what is going to go onto your cylinder, and this, you have a circle here. What you do is, you fold along this. We have put cuts, so we will be able to fold and glue it. Now how to fold, we are going to talk now. And that is, folding comes with the flat surfaced solids. For the flat surface solids, we have certain practical tips or hints. The first thing is that we are going to do it with a paper, but the paper has to be a little thick, preferably chart paper or some card paper like this one. Like this is a little thick, or this one is still thicker. So that is one thing. The second thing is that when we make the model, we'll have to join. Like suppose I want to make a cube. I'll take 6 squares. So easy, glue them up. It's not that simple. Because if you want to glue 2 squares, what will happen is, here is say 1 square and here is another square, and you try to glue it, either there will be some space left over because the edges are very thin, or they will overlap and it will not be mathematically exact. And so we want to avoid edges or joints as far as possible. How do we do that? There have to be some joints. So we draw a figure in which there will be less joints. For example, for this cuboid, what we can do is, suppose it is cut from here. If it is cut from here, this will fall apart this way, this will go this way. So we will have 1, 2, 3 and 4 in a line, one at the top, one at the bottom. And all these joints we shall not have to do. These 4, 5 and 6 joints will be eliminated. So such a drawing is called a net. So the first thing is chart paper. Second thing is, we will take a net with the least possible joints. Thirdly, there have to be some joints. There is no way out. For those joints, what we do is exactly what these people have done in the market. You can see here, they have not glued it, that's all, because they want to keep it open. But there is a little tab here and this can fit on it. So instead of having the joint just like this, they have the joint like that. And so it will be perfect, it will not give way. What we do here, for example, I will show you is that the joint, suppose I want to join this. Suppose I want to join these two. What do? We don't join just like that. What we do is, on this one of them, you can see what I did. I drew a little line here. I did not draw, but I just took it on the scale. There was a line here, and on that I pressed with this compass point on that line. And now what I will be able to do is, I will be able to fold this exactly. The corner will be perfect. If you just fold it like this, it will be rounded. This will be perfect corner. On this now, instead of joining just like that, we join on this, we put this. And so it will be a perfect joint and it will not move easily also. So that is the third thing, that chart paper, minimum number of joints, and so net. And thirdly, wherever there are joints, we will have an extra tab like this, on which we shall put the other thing that is to be joined. Now this tab, or wherever it is to be folded, for example, here also you want to fold here. So wherever you have to fold, you do the same thing that I did just now. With the end of the compass, you pass it on 2 or 3 times. It will just cut the upper layer of the paper. We call it scoring. And in that case, once the upper layer is cut, it is easy to fold it. But remember, the folding will be inside. Like I did scoring on this side and the paper was folded on the other side. So our scoring will take place on the right side because the flap or the joint will go on the other side. Okay, so our drawing has to be very careful, less of erasing, and draw with a pencil very lightly so that even if it is not accurate and you want to erase it, you can do it without spoiling the outside of your surface. And be very accurate in your figure. Okay, with this much in mind, we start with the second part of the models. the models having flat surfaces like a cuboid, a prism, a pyramid, and so on. Now, for that, what we have to do is, first of all these with flat surfaces, flat is not the right word, plane surfaces. The plane surface, we don't call it a side of the model or the side of the solid, we call it a face of the solid. So, for example, this cuboid has 6 faces, or this prism has 5 here and 6 one. This has 6 faces, and so on. Now, these are called polyhedra. The singular is polyhedron, the plural is polyhedra. Now, so we are going now to make models of polyhedra, and for that purpose we are starting with a chart paper. I am going to show you one model. We will make one model here. It will take some time, but then all the models are done in exactly the same way, the only difference being in the net, depending upon the shape of the solid. So we start with a pyramid. Now by the way, these nets are all available on internet. They are available with tabs and without tabs. So you can easily take the nets from the internet and make your own models. I'm just showing you the practical hints, giving you practical hints and showing you how we can make one. Now, this is a pyramid. What I did was, I've drawn it with ink, which is not really good. I should have drawn with pencil. But with a compass, I drew a circle because I wanted equal sides. And then I marked off some lengths, all equal lengths. I wanted 6 sides, so I took 6. If I wanted 7, I would have taken one more, or one less, whatever. So now I want to make a 6, it is obvious here, I want to make a pyramid with 6 sides. They are called lateral faces, which are sort of vertical. And therefore the base will also be, we have seen that last time, it will be a hexagon. So I have drawn on one of them, I have drawn a hexagon. So now you will see that we have eliminated so many joints. For example, this will go here, that joint will be there, but 1, 2, 3, 4, 5 joints are gone. The 6th joint is also gone. So we'll have to have 6 less joints. But now, wherever there are no joints, there will be folds, including those at the tabs. There will be a fold here, there will be a fold here, and so on. For the fold, this is what we do. As I told you, scoring. We normally use a steel scale. And this is how we score. Now, I will not score all of them right now, but I have one which I have already scored. Here is one in which I have done all the scorings, and then at the scoring, what we do is we fold. And now you can see that I don't even have to bother whether my line goes from here to here or here to there. It will fold. If the scoring is wrong, it will fold wrongly, but otherwise it will go exactly on the score. And here also I have scored, so you can see that this is also perfect. But if I try to fold here, it will not be there, and therefore I will not try to do it. But this is how we fold. And this is what we get after we have folded. This is the tab that we have folded. These are the six sides, and this is the base. So we have scored, we have folded, And now all that remains is to glue up. Take some Fevicol, and this tab should go inside and this should go exactly on it. This is how it should join. Alright, once this is joined, what we have to do is, the base has to be glued, all the tabs go inside, as you can see, all the tabs have gone inside and they have been glued here, and the pyramid is ready. So this is how we make a polyhedral model. Now what remains to be done is the nets for all the remaining ones, and do exactly the same thing. Draw the nets, score, fold, glue. I'll put this away because I don't, this is only for scoring. Okay. And now we have to try to see how we can make a net. To make a net for pyramid we have done already. Now prism. For the prism, if we open up one of the, along one of the vertical lines, then all the faces, some will go on this side, some will go on this side, and you will have, this has 6 faces, vertical faces, you will have 6 faces in a row. And then this will go at the bottom and a similar one at the top. So we will draw like this. Now remember, this is for a prism. Pyramid, it was something like this. Now the figure is not exact, but I have shown you, so I don't care much. And then you have tabs at these 4 places and these 5 places. That was for a pyramid. And now for a prism, we just saw, suppose we want a prism with 5 sides, or say 6 sides, whatever. Then what have we done now? We have taken 6 vertical faces. They are all rectangular, so we have them all in a line, and there is this tab at the end. Why? Because this tab will go over to this, and you will have all this will go around, and you will have the whole rectangular faces glued up, all the 3 faces glued up. What remains now is the base and the top. There are 6 sides, so we want a hexagon. Now you know how to make a hexagon. Remember, it will have to be the same length. This length has to be common. So suppose we take a hexagon here. We want a hexagon with this length, and you know how to make it. With this radius you draw, so you get an equilateral triangle. This will be your center. Draw a circle, and then this will be the hexagon. And you do the same thing here. And of course you have tabs either here, or if you are more comfortable, you can have the tabs here. Because each one of this will touch or will be glued with one face of the rectangles. So here also, and of course we have taken this, and what we have is, as you can see here, this is a prism with 5 sides. We have made a prism with 6 sides, but the net will be something like this. Alright, what about the cuboid? The difference between a prism and a cuboid is only this, that here all the faces, lateral faces, vertical faces are the same, congruent. Here they are congruent, these two are congruent, those two and those two. That means the opposite ones are congruent. So now let us see what will happen. And if you open up, like, it will be exactly like this. So this is one face, this is another face, 2 rectangles. This one is this one is this. Now third one, these two I can draw any size. But what about this one? It has to be congruent to the one before, so the previous one here. So we have taken all 4 of them just like this, and now we will have a tab at one of these ends. So this will glue up with this, and the 4 sides are ready. Now top and bottom. They are also rectangles, same size, but now we cannot choose any rectangle that we like because it will have to fit on one of these. So suppose we take a rectangle here. So one side is fixed. What about the other side? Well, this side has to glue up with this. And so these 2 sides must be the same, otherwise they will not match or fit. And so these 2 sides must be same, and naturally these 2 will be same. And then this is of course congruent. And now the flaps. You can take the flaps as we did here, all these. Or you can also do it like this. Take one here, one. Leave this one. Leave this, take this. 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 Now, the checkpoint would be that when we did these alternate ones, this we did not take a tab, but we know that this tab is going to come here, so we did not want a tab here, so things are right. Okay, so this is for a cuboid. And now for a cube, cuboid, yes. And now for a cube, well, cube is just like a cuboid, except that instead of 3 sets of congruent pairs, you have all 6 squares, and then they are all congruent. So it will be something like this. And then same thing. Whereas these 4 will go together and they will form the 4 sides of the cube, and these will be the 4 sides. The top is here and the bottom is here, and what will happen is these will go like this will fall in, this will go up, and you will have the cube. And the tabs, well, the points where I put points, those sides will have tabs. Okay, so that takes care of the cube. So we have tried to see the models for cone and cylinder, and then for polyhedra, prism, pyramid, cuboid and cube. There are other special kinds of polyhedra whose models also we want to make. They are very interesting models and a very interesting polyhedra. But we first have to understand something about those polyhedra before we make these models. So we'll take that in the next session. Well, okay, try to do this, and I hope you will be successful be a little patient, be very accurate in your drawing, because if your cube, if this angle of your cube is not perfect 90 degrees, or if this length is longer than this length, your corners will not match. So you need to be very careful. Okay, good luck, thank you.